This one is we want the conjugate base of this. We want to think that a base, it donates a proton. And so the only protons are on water. There's 6 of them, so we want to 6 waters, 12 hydrogens, we're just going to get rid of one of them. So you pick one of the waters, it doesn't matter which one. So take 1 out of the 5 and remove a hydrogen from it. So now instead of H2O, just 1H1O. And now, remember you're removing an H plus, so we're taking out an H plus out of this. So it's going to go down in charge by 1.
Why not we can just decrease the charge by 1 without taking an water?
If you go down by 1 in the charge and keep 6 waters here, that makes this a ferrous ion. So you do decrease the charge, but
it's not a base.
it's not necessarily a base. It's still actually potentially acidic, but it needs to either donate a proton or receive an electron pair if you want to do the Lewis definition. So if you remove a proton and don't gain any electrons, it doesn't fit either definition.
Do you have another example, please?
Do you have another
I only
example?
see once appeared to the 12 example. I don't think I need another one.
Oh, okay. Not really. It's just because I thought of it that year.
What's the question for this?
The question is, if this is an acid, what's a conjugate base? And there's 4 choices or 5 choices, and this was the answer.
Okay.
Yeah. Yeah. So, I don't really have a good example of another one to do, because they would all be extremely similar to this. So, say we did copper, well, it's even hard to think of an example that would be anyway different. Let's try this. If that's the acid, you do the same thing. If you want the conjugate base, there's 4 H2S's, take out 1 out, and then that would be neutral because you're removing one of the protons.
Okay.
Yeah, they really wouldn't be different than